Hi students, in this video we will discuss about TCP stream communication, issues relating to stream communication, failure model and finally uses of TCP. Let us see what is meant by TCP, which stands for Transmission Control Protocol, and it is a standard which defines how to establish and maintain a network conversation through which the application programs can exchange data. TCP works with Internet Protocol, which defines how two computers can send packets of data to each other. Also, TCP is a connection-oriented protocol. That means if two processes want to communicate with each other, they must establish a connection beforehand. Only after setting up this connection, the sending and receiving process can exchange data between them. Hence, TCP is a connection-oriented protocol. It is also known as stream communication because TCP keeps the stream of data between the sending and the receiving process during the transfer time. Now let us see some issues or challenges relating to stream communication. First one is flow control. That means there should have a speed match between the sending and the receiving process. That is, there should have a speed match between the reading and the writing process. Suppose think that the process which writes is too fast for the reader. So what will happen? The writer has to be blocked until the reader has consumed some sufficient amount of data. So in TCP, a flow control mechanism will make an attempt to match the speed of the processes that read from and write to a stream. Next one is message duplication and ordering. We know that in order to have a reliable communication, there should have a validity as well as integrity. So in the case of a TCP protocol, message identifiers are associated with every IP packet so that the receiver will be able to detect and reject the duplicate packets. It also helps the receiver to reorder the messages which has not arrived in the correct order sent by the sender. Next is lost messages. The TCP protocol always uses an acknowledgement scheme. That means the sending process will keep a record of each IP packet it had sent, and at the receiving end, the receiver will give acknowledgement for all the packets it has received, so that the sender will get an acknowledgement from the receiver if that packet has correctly reached at the destination. And within a particular timeout, if the sender does not receive this acknowledgement, sender will think that that packet has not reached the destination and it will retransmit the message. Next challenge is message destinations. We have already stated TCP is a connection oriented protocol, so that any communicating pair of process should establish a connection between them before sending of the messages. So once this connection is established, the process can simply read or write to the stream, and it does not need to use the internet address or the port address further. So in this TCP protocol communication, the processes are considered as client and server. So in order to establish the connection, first the client has to send a connect request to the server, and the server should accept the connect request. This is the typical flow of events for a connection-oriented socket. We have stated that the processes are considered as client as well as server. So in order to establish the connection, both the client and server should have a socket at each end. Socket is nothing but it is a one endpoint of a two-way communication. And since the client is the process which accepts some request, which request some uh, kind of services, and the server will provide the services to the client. So client will create a socket and it will pass two parameters. One is the IP address and the other one is the port number. IP address is the address on which this particular server resides. So after creating the socket, client will bind it to any of the port and it will send a connect request. This is the connect request to the server. At the same time, server is also having a socket. It will bind it to the server port and it will be listening in that particular port. Okay. So when the connect request from the client has arrived at the server, server will accept the request, which is shown by this block. It will accept the request and it will create another socket and will establish a connection to the client, which is shown by line 6. It will establish a connection to the client so that the client and server can communicate through this newly created stream of communication channel, which is shown by line number 6 and line 7. After that end of communication, both the client and server will close the sockets. Now, any application programming interface for stream communication will consider that whenever a pair of processes is establishing a connection, one process will act as the client and the other process will act as the server. Now let us see in detail how this connection establishment is taking place between the client and the server process. Okay, since the client is the one who is seeking some request from the server, always client will take an initiative to establish the connection. So that client has to create a socket which is a parameterized socket. That means it will pass the IP address of the server as well as the port number and it will send a connect request asking for a connection to the server at its server port, which we had seen in the previous figure. So the server will also create a listening socket and it will bound to the server port and will wait for the client to request connections. So client has sent or created a socket and sent a request and server has also created a listening socket and it is waiting for any request connections from the client. The server also maintains a listening socket of incoming connection requests. Now, whenever the request has arrived at the server and server accepts a connection, server will create a new stream socket for the server to communicate with the client. But at that time also, the listening socket will be listening for connect request from the other clients so that a new connection is established between the server and the client and the pair of sockets in the client and server is connected by a stream of communication, one in each direction, which had seen by lines 6 and 7. A stream of communication is established between the server and the client, one in each direction, so that each socket will have an input stream and an output stream. Okay. Now, when one pair of process want to send an information, it can write this into the output stream and the other process can read the information by reading from its input stream. So, after the exchange of messages, whenever an application closes a socket, this will show that that application cannot write any more data to the output stream and any data which is present in the output buffer will be taken to the other end of the stream and will put in the queue at the destination socket with an indication that the stream is broken, so that the process at the destination can read the data in the queue. But if the process tries to read more data even after the queue is empty, it will result in an indication of end of stream. Similarly, whenever a process exits or fails, all of its sockets are eventually closed and any process attempting to communicate with it will discover that its connection has been broken. Now let us see some outstanding issues related to stream communication. First one is matching of data. That means there should have a match of data between the sending and the receiving process. For example, consider that one process had sent a int value followed by a double. So the reader should also read that message in the same order, that is an int followed by the double. If this cooperation among the process is not working, the reader may experience some kind of errors. Next is threads. Think that the client has sent a connect request, server has accepted the request, and server will establish a new connection with the client so that a new thread is created and it will in which communicate with the new client. One advantage is that the server can work with multiple clients at the same time and there is no need to delay the other clients. And in an environment where thread is not provided, one alternative method we can use is check whether the input is available from a string before attempting to do a read operation. Next challenge is blocking. So the data written to a stream is kept in a queue at the destination socket. And think that a process tries to read data from the input channel. If the data is present, the reader can read it. Otherwise, the reader will be blocked until the data becomes available. Similarly, the process that writes data to a stream may also be blocked by the TCP flow control mechanism if the socket at the other end is queuing as much data as the protocol allows. That means if the writer is too fast when compared with the reader, the writer will be blocked. Similarly, if the reader is too fast, it will be blocked until some kind of data is present in the queue to read. Next is failure model. We have already stated that to have a reliable communication, it must satisfy the integrity as well as the validity property. So, in order to satisfy the integrity property of reliable communication, TCP stream uses checksum and sequence numbers. Checksums are used to detect and reject corrupt packet as well as sequence numbers are used to detect and reject the duplicate packets. Now, to have validity property, TCP uses timeout and retransmission to deal with the lost packet. Therefore, we can say that messages are guaranteed to be delivered even when some of the underlying packets are lost. But think of a situation if the packet loss is more and the network is heavily congested, so that the TCP software, which is responsible for sending messages, will not receive any acknowledgement, and after a particular amount of time, it will consider that the connection has been broken. So we cannot say that TCP provide a reliable communication because at some of the possible difficulties, that means if the packet loss is more or the network is heavily congested, it cannot guarantee to deliver messages in the correct order. And when a connection is broken, any process using it will be notified if it attempts to do a read or write. This has two following effects. One is that the process will not be able to distinguish whether it is a communication channel failure or whether the process at the other end had failed. Similarly, the communicating process cannot tell whether the messages they have sent has been received or not. Finally, some of the uses of TCP are uh, HTTP, that is hypertext transfer protocol, is used for communication between web browsers and web servers. FTP, file transfer protocol, which is used to transfer files from one computer to another. Telnet, which provides access by means of a terminal session to a remote computer. And SMTP, simple mail transfer protocol, which is used to send mail between the computers. By this, we have concluded TCP stream communication. Thank you.